When you're cutting thinner gauge metals, the problem you run into is that the metal gets so hot from the preheat flames that the slag sticks in the kerf and kind of welds the metal back together. If you're using a triple-aught tip, you can make a pretty good cut, but more often than not, these cuts are made with a tip that's too big. Try holding the torch at a steep angle in the direction of the cut and go fast. Keep moving. If you hesitate at all, the metal will glue itself back together. Now, anytime you put heat to gauge metals, they will warp, especially on larger pieces. If this will affect the project you're working on, you can have the pieces sheared to size. All the cuts we've made so far have been in the flat position. If you're cutting across or horizontally, everything works about the same. For a vertical cut, you can either cut uphill or downhill. On thinner metal, you get a nicer cut traveling down because the heat's rising and you're cutting into cooler metal. On thicker metals, I like to cut up because the metal's being preheated a little. Also, if the slag isn't blowing clear, it's running down on the backside and you're cutting up into clean metal. One of the biggest factors in determining whether you cut up or down will be where you can position yourself to see the cut line. To help in making straight cuts, you can use a straight edge. And there are a lot of different styles of homemade or shop-made straight edges. This is a piece of 1-inch pipe welded to a vice grip. You can clamp it on a piece of flat bar, rest the tip against the pipe, and make the cut. A straight edge helps hold the torch steady and lets you concentrate more on a smooth travel speed. I like to use a piece of 1-inch pipe with a 1/2-inch round stock handle. It's easy to move around and good for awkward cutting positions. This one does take a little getting used to because you only get to hold the torch with one hand. This is a magnetic brass straight edge for cutting plate. Magnets hold it in place along the cut line and you can make longer cuts without stopping. These straight edges are handy, but they don't automatically guarantee a good cut. Before you can use these effectively, you need to know how to handle the torch. Now, when you're preparing metal for weld joints, you'll sometimes need to bevel the edge. On metal that's 3/8 of an inch or less, you can just grind the bevel. On thicker metals, it's easier to cut the bevel with a torch. Bevels are generally around a 30-degree angle, and ideally, the top edge should be straight. You also want to leave a flat spot called a landing on the bottom edge. When you're welding, the top edge acts as a guide to keep the finished weld bead straight, and the landing helps carry the heat so you don't burn the bottom edges away. Before you start, you can draw a line as a guide. Angle the torch so you're not cutting through the bottom corner. Because a lot of the heat is just blowing off the edge, the cut speed will be slower. If the cut stops, let off the cutting jet lever, jump out to the edge, preheat, cut back to the line, and keep on going. Using a straight edge to bevel helps keep the torch steady. On long bevels, cut out to the edge, reposition yourself, cut back into the line, and go again. You'll probably get slag sticking to the bottom edge because of the slower travel speed, but it comes off easily. Another situation you'll run into is making a cut where you don't have an edge to start on, like making a cutout for a pipe to go through. Start inside the cutout and preheat a little more than you would on the edge. Ease the cutting jet lever on and start moving the tip. The slag will come up in the kerf until you're all the way through, then move up to the line and make the cut. By moving the tip on the start, the slag won't jump up and contaminate the tip. And if it does, take a few seconds to clean the tip. Occasionally, you'll get in the position where you need to save both the inside and outside pieces. So you'll have to start right on the cut line. Here again, preheat a little hotter, ease on the cutting jet, and move the tip. When you're all the way through, cut back just a little, then go on to make the cut. You're able to cut back through the slag because everything is still hot from preheating for the start. By cutting back a little, you'll have a relatively clean place to finish. If you leave that mess, when you come all the way around to finish and the cutting jet hits the cold slag, it'll probably gouge into the sides of the curve. Now, cutting torches like this don't like to cut through two pieces of metal at one time. Sometimes you'll get lucky, but most of the time, the second piece won't get hot enough, stopping the cutting jet from getting through, and the slag comes back up in the curve. The best you can do is to angle the torch and wallow through the top piece, blowing out the slag until you can preheat the bottom one. And this is never pretty. When you're through the first piece and preheating the second one, you need to be careful the tip doesn't get so hot that it melts. Besides cutting flat bar or plate, sooner or later you want to cut some solid round stock or rebar. These don't have an edge to start on, and keep in mind how thick this is so you can adjust the oxygen pressure to get all the way through. Get the metal good and hot, rotate the tip back a little, push the cutting jet lever, rotate the tip straight up and down, and cut it off. If you're cutting rebar, the higher ridges will get hot faster and give you a quicker start. When you're cutting pipe, you want to keep the tip of the torch pointed at the center of the pipe. Use a pipe wrap to draw a line for a square cut. If you can spin the pipe, try starting on the side and cut to the top. The cut line is easy to see, and the torch is in a comfortable position. Slag will probably stick to the inside, especially on thinner walled pipe, but you can make a good square cut. Even if I'm not able to roll the pipe, I still usually start on the bottom and cut to the top, mainly because I can see the cut line better. When you're fabricating in the field or making repairs, you may need to burn a bolt hole. I like to make cross lines for a reference to help keep it round. You don't have an edge to start on, so get the metal hot, ease on the cutting jet, and move the tip. When you're all the way through, circle the torch, making the hole a little bigger every time, using the cross lines to keep the hole centered and round. You'll probably end up with some slag on the bottom side, but with practice, you'll be able to drill some pretty nice holes with a torch. For bigger holes, or if you need to cut round pieces, you can use a circle burner. The torch fits into it, and there's an adjustable point that you put in a center punch mark on the metal. Preheat fairly hot and ease into the start, keeping the tip moving. Cut back a little, then just pivot it around. If you have several holes to cut, this saves layout time and all the holes are identical. In making repairs, you may also run into the situation where you have to cut apart a T-joint. You can cut just above the weld, then start slicing it off. When you get close to the base, you start washing off the metal. Back the torch away and ease off the cutting jet lever to slow down the cutting jet. Watch the back side of the cut stream to make sure it's not gouging into the base metal. You can get pretty close washing that metal off, and it saves on the grinding time. In repairs or mechanicking, you may run into nuts and bolts that are rusted on so hard that you have to cut them off. On a bolt head, don't go for the whole thing at one time. Start at the top and slice it off. When you get to the bottom, ease off the cutting jet and wash it off, taking care not to gouge into the base metal on the back side of the cut. Small nuts that are rusted on can be cut off the same way. The whole thing will get hot enough to slice through both the nut and the bolt. On larger nuts, you won't be able to get all the way through. An easy way to get this off is to cut right alongside the bolt. Jump to the other side and do the same. Then use a hammer to knock the pieces off. Now, some of the bigger bolts are expensive, or you may not have another one available. So you can cut the nut off and leave the threads to reuse the bolt. It works about the same way as cutting the nut off. Only make the first cut away from the bolt a little, then wash it off. As soon as the threads pop through, you have to quit or you'll nick the threads. I guarantee that when you do that for somebody, you'll fool them into thinking you know what you're doing with a cutting torch. Now, we've been washing metal off with a regular cutting tip. This is a scarfing tip. The tip is angled so the oxygen cutting jet is parallel to the metal. This helps to keep from gouging into the metal on the back side. The cutting orifice is also larger to slow down and spread out the cutting jet. This tip can be used to remove weld from a joint where both pieces are going to be saved, and to gouge out a bevel while making repairs. Well, that's about it. I hope I've given you some ideas on how to handle a torch. You really won't know it though until you do it and see it for yourself at the end of your own cutting torch. Remember, keep your tip clean, get comfortable before you start, and concentrate on the cut while it's happening. Know where your sparks are going, and look up occasionally to check for fire. There's one more thing we need to do yet. When you're finished, like rolling up at the end of the day, you want to bleed the pressure off the system. Close both bottle valves. And starting with the acetylene, open the main torch valve. When all the pressure bleeds off, screw the regulator adjuster out so the next time the bottles are open, the internal diaphragms don't get hammered and there's not a lot of friction inside the regulator from the surge of gas. Close the torch valve and bleed the oxygen the same way. And you're finished. Have fun with this, and above all else, keep safety first.